Hi, Biotech TV. I was just reading a recent issue of Science, and there was an article and a piece of research in here that caught my attention. So the title of the story was Improving Alzheimer's Disease Immunotherapies. And the research was published by a group of researchers from Denali Therapeutics and Biogen. The issue here is that it's hard to get drugs like antibodies into the brain because our brain naturally has the blood-brain barrier that's meant to be a fortress to keep things out that you don't want to have go into the brain. The researchers from the Science paper and others are using something called the transferrin receptors of endothelial cells as a natural transporter to get more drugs across the blood-brain barrier. A year ago, I had the honor of interviewing the inventor of the approved Alzheimer's treatment Leqembi, Lars Lonsfeld, in Sweden for Biotech TV, and he thinks these types of approaches are going to be transformational.
And if you want to hear what I think about the future, I think it will be brain transporter, because antibodies are very poor at penetrating into the brain across the blood-brain barrier, and now we have technologies increasing the penetration, and if we manage this, and I'm sure we will do this, we might increase penetration 10 times. There are indications also that it will penetrate much better into different areas of the brain, and the side effects will probably go down.
More recently, a couple of weeks ago, I interviewed the CEO of Elector Therapeutics, who's also working on this.
Fundamentally, the technologies are very similar, but there are subtle differences that could really make or break the technology. One of the side effects of the technologies, for example, is anemia or hematologic side effects, because there is a lot of transferrin receptor on red blood cells. And if you deliver a lot of the drug to red blood cells, you can also recruit immune cells to this complex, and then you damage the red blood cells and cause anemia. So there are a lot of subtleties in where your blood-brain barrier shuttle binds on the transferrin receptors, what's the affinity of the binding. It's really, you have to thread the needle between safety and efficacy, and different companies are doing it differently, and I think some technologies will be superior to others.
The Denali and Biogen research team from the paper believes that their secret sauce is how they've designed their construct to have Fc domain mutations that are asymmetrical rather than symmetrical. So we'll have to follow this space and put the transferrin receptor and getting drugs more efficiently across the blood-brain barrier on our radar.